Hi, John here. Today we're going to look at the globe valve. I'm going to explain to you how it functions. We're going to look at some of the main components, and finally we'll look at the advantages, disadvantages and applications for this type of valve. As we can see, we've got a globe valve in front of us right now, and we can see that it's being actuated. It is now in the fully open position, and it is now in the fully closed position. Let's just quickly turn the valve into its normal view, in other words the view that we would see when it's installed. Do a little spin. We can see we've got a flow indication arrow here, and that's telling us that the flow is coming in on the left hand side, that would be the inlet, and it's going out on the right hand side, so this port here would be the outlet. Let's take a cross section again. This type of valve actually gets its name not from the shape of the disc, which is unusual because normally valves are named after the type of disc they use, but it is named after the shape of the body. This is slightly confusing because other valves also have a globular body shape, but for whatever reason the name is stuck and we now call this type of valve a globe valve. Globe valves are used to start, stop and regulate flow, and they are linearly actuated valves. The reason we can use the globe valve to regulate flow is because as we open the valve, it travels linearly upwards, and as it moves away from the port, we are proportionally allowing more and more flow through the valve. So this is different to a gate valve, where if we open the valve slightly, the amount of flow is not proportional to the opening and the flow velocity through the valve is very high. With globe valves we don't have that problem, and we can use the valve for throttling. Let's just have a look at the top of the valve and talk about some of the components. We can see that it's got what they refer to as a rising stem. The rising stem indicates the valve's position. Now the valve is open, we can see the stem is popped out of the top, and now the valve is closed. We can see also that the valve is mechanically actuated because we're using a hand wheel. We have here a follower, that is this metal plate here, and this piece. And if we were to tighten, let's just go to a full view. If we were to tighten the nuts here on the left hand side and on the right, and the same on the bottom side, then we would actually force the follower to press down on the packing gland, and this would tighten the seal between the bonnet and the stem. So let's have a look at a few of those components now so we can figure out how the whole thing works. So we tighten up this plate, the follower plate. It's going to push down on the gland, and as we do that we're actually going to put pressure onto this black area here, this packing. And as this is compressed, the packing is going to be squeezed against the stem, this piece here, and the bonnet, which is this piece here. And that's what gives us our seal, and that's what prevents the valve from leaking